Welcome back to our course, Mastering OEE in Manufacturing. In today's lesson, we'll move on from Nakajima's method for calculating OEE and look at Factbird's waterfall approach. This is a more modern approach to calculating OEE and has been helping manufacturers worldwide since 2016. In this slide, we'll look at an overview of Factbird's OEE waterfall. You'll see that the terminology is slightly different from the Nakajima OEE method, and we've added another level called total equipment time. The total equipment time represents the plant's total potential operation time. When we know this, we can also optimize the time where there is no planned production in our improvement efforts. This means that you can still separate out unmanned non-production time if you have lack of orders, don't work weekends, or operate one shift a day instead of 24/7. Otherwise, man time, production time, operating time, and valued operating time are similar concepts to those introduced by Nakajima, but with some differences in how we allocate downtime losses. So here, the valued operating time is at the core of everything. This is the time that we want to increase because this is when our production line or equipment is creating value. The valued operating time is the value that the other measurements are compared to when calculating OEE1, OEE2, OEE3, and finally TCU, which means total capacity utilization. And these are the values that we will look into now. Here, OEE1 looks at the ratio of valued operating time to the operating time, also described as the expected runtime. The stop causes that affect this are categorized as loss during operation. You get OEE1 by dividing valued operating time by operating time. In practice, you can say this is the produced amount over the validated speed, then divided by time producing. When you know OEE1, you understand the amount of time your production line has actually had available to produce units and the amount of time it has actually spent doing that. OEE1 takes into account any unplanned downtime, and everything else is not taken into account. As you can see here, potential OEE1 stop causes are something like machine defects, process defects, waiting time, IT-related stops, or even unplanned cleaning. To put OEE measurements in context, let's take a look at the OEE dashboard in Factbird's cloud application. Factbird automatically calculates the different OEE scores based on the automatically collected parameters on your shop floor and the stop causes inputted by your operators. The OEE snapshot we're looking at covers a period of 720 hours or 30 days for a large FMCG company. During these 720 hours, we've had 500 hours of operating time where we should have been producing product, and out of that, we've been online for 292 hours. This leaves us with a 58.3% OEE1 score. OEE2 takes into account the time a production line is not running due to batch changeovers, resupplies, and cleaning. We call these stops batch-specific non-operation. OEE2 is calculated as valued operating time divided by production time. In practice, this is produced amount divided by validated speed divided by time doing batch-related work. Although these stops are planned, they take a significant amount of time from the total available time. Manufacturers tend to focus on the OEE1 stops the most because they're unplanned and annoying. But I'd recommend spending just as much time looking into the planned stops and seeing how you can optimize them as well. Potential OEE2 stop causes are things like batch changeovers, resupply, and cleanings. As you can see in this example, we've had 520 hours of production time over 30 days. Once again, taking the total valued operating time of 292 hours into account, we get an OEE2 score of 56.1%. OEE3 accounts for all the planned stops, such as meetings and training. We call this category of stops non-production activities. You get OEE3 by dividing the valued operating time by the man time. In practice, this is produced amount divided by validated speed divided by manned activity time on the line. As you can see here, some OEE3 stop causes are planned maintenance, quality inspections, and personnel activities like meetings or training. As you can see in this example, our man time is 521 hours. This leaves us with an OEE3 score of 56%. Finally, TCU takes into account planned downtime due to vacations, company breaks, or simply no planned production. The TCU is the valued operating time divided by the total equipment time. In practice, you can say this is the produced amount divided by validated speed divided by total period of measurement. If TCU is 100%, then your machine, production line, or plant is running at 100% capacity. And honestly, then you should be teaching this course. In reality, if you are in or near this situation, you then know that the best thing you can do would be to increase production time. In this example, our total equipment time is 720 hours, which is 30 days at 24 hours a day. We end up with a TCU of 40.5% after dividing the total equipment time by 292 hours of valued operating time. And that's all for today. In the next lesson, we'll take you through an OEE calculation example using the Waterfall method to help you further understand OEE calculations. See you next time.